Ethereum Classic is a global computer. Bitcoin as a payment system. As we noted in our previous post, Bitcoin's amazing invention was not really digital money, peer-to-peer networks, or even proof of work, POW. The real invention was to use the proof of work itself as a consensus mechanism to enable sound digital money in a truly decentralized peer-to-peer network. Proof of work consensus unlocked the door to synchronize computers on the same state of the data on a global scale with no need of central arbiter or administrator. This was the crucial discovery that changed everything. However, Bitcoin is a very basic system. It only moves coins from one account to the other, nothing more. Hence, it may be said that Bitcoin is really a payment system. Ethereum Classic is a global computer. The next generation of blockchain technology would be the same as Bitcoin but programmable. This is how Ethereum Classic ETC was designed. ETC has the same basic structure as Bitcoin but includes smart contracts. Smart contracts are enabled by a technology called Ethereum Virtual Machine (EVM), a Turing complete programming language called Solidity, and a transaction fee payment mechanism called the gas system. Combined, these components on top of the basic structure of Bitcoin created a global computing system that may be used to program the money of the protocol. Hence, ETC is a decentralized global computer rather than a payments system. The limitations of ETC. However, ETC may not be considered a decentralized cloud service. Traditional centralized cloud services put enormous amounts of computing power and storage capacity at the service of corporations and the public. These infrastructures may easily handle and process big data, artificial intelligence, and machine learning applications. These technologies require ample computing capacity and data storage. ETC, because all the information and execution of software programs must be fully replicated and handled in parallel in all the computers of the network so that it may remain decentralized, is very inefficient and, consequently, has a limited data storage and computing capacity. Social scalability. Nevertheless, this computing and storage inefficiency is actually purposeful. In ETC, there is a deliberate trade-off between computing scalability and what Nick Szabo, a blockchain pioneer, termed as social scalability. Social scalability means that the system is permissionless and censorship resistant. It means that anyone in the world may use it as long as they are following protocol rules and they will not be limited in their access. Traditional systems may scale computationally to handle large computational and data tasks, processing big volumes of transactions per day, but because they must be centralized to offer this efficiency, they will impose restrictions and barriers according to political correctness and ideological bias. ETC does away with these barriers at the cost of computational and data scalability. Decentralized applications. So, if ETC is a decentralized, thus secure, uncensorable, and permissionless global computer, but inefficient, what is it good for? Well, it turns out that there are many use cases that are still valuable because of ETC security. Some examples may be decentralized exchanges. Decentralized exchanges are critical infrastructure in ETC as they provide a way of exchanging assets without the risks and restrictions of trusted third parties. Stablecoins. Stablecoins have proven to be an enormous use case, especially in third world countries where people needed a way to get a hold of stable money to hedge their rapidly devaluing national currencies. NFTs. NFTs are also critical infrastructure as they not only may be used to represent art that can be traded on the blockchain, but they may represent many other kinds of assets, even in the real world. Property registries. Some of these assets may be represented on the blockchain as NFTs are real estate and vehicles. These will be bought and sold on the blockchain, and the property titles and loans against them will be executed seamlessly on the same action, shortening settlement times from days, weeks, or months to seconds. Web3. Speaking of use cases, another kind of application of a decentralized programmable blockchain or global computer as ETC is to serve as the backend code of decentralized web applications. The concept of decentralized web applications, or the Web3, stemmed from the understanding that the first websites were static, hence they were called Web 1. Then, social media websites revolutionized the world by enabling dynamic, user-generated content and was called Web 2. And the next generation will be a web with decentralized and censorable applications, which is why it is called Web 3. ETC is as a global computer will serve as the core code of these applications, handling the security and the underlying value, and other decentralized networks will provide file storage, image management, scalability of transactions, and other features. The layered future of the blockchain industry. As all these different components evolve, the topology of the blockchain industry will more and more look like as a layered ecosystem where ETC will likely be a base layer secure technology that will handle backend code and large amounts of value. Above this base layer, there will be proof of stake and scalability solutions that will enable larger volumes of smaller transactions. There will also be file storage and other solutions that will enable the full vision of the Web 3. Above this second layer, a third layer with decentralized applications will provide the end-user services such as decentralized exchanges, lending and deposits services, NFTs, stablecoins, and property registries, among many others. And finally, the fourth layer, or user-facing layer, will be the wallet, web, and mobile apps that users will use to interact with all these systems. Thank you for watching this Ethereum Classic video. To learn more about ETC, please go to ethereumclassic.org. Thank you very much.